Okay, let's unpack this. There's a huge problem brewing in the world of large language models. For years, these LLMs, they've been trained on just absolutely gargantuan amounts of text. But here's the kicker. A lot of it, maybe most of it, has been unlicensed. And this whole practice, it's sparked some really intense legal battles, huge IP concerns, and, well, ethical minefields, frankly. We're seeing lawsuits just pile up against the big LLM developers and content creators. They're pushing back hard. You saw that sharp increase mid-2023, right? Websites blocking AI crawlers left and right. But what if there was another way? That's what this groundbreaking new paper asks. Can we train powerful, really performant language models using only public domain and openly licensed text? And the answer they came back with is a pretty resounding yes. Their main contribution. It's called the Common Pile v0.1, an absolutely colossal 8-terabyte dataset. And get this, it's the largest known collection built exclusively from openly licensed and public domain text. Now, to prove it actually works, they trained two pretty impressive 7 billion parameter LLMs, v 0.11t and v 0.1-2t, entirely on this ethical data. And here's the real game changer, these comma models. They achieved competitive performance. They went head-to-head with LLMs trained on, the usual vast amounts of unlicensed data, models with similar compute budgets like Llama 1 and 2.7b, and they basically held their own.
Yeah, what's fascinating here is that this isn't just some moral victory, though it is that too. It's a practical demonstration. It shows that top-tier performance doesn't have to come at the expense of intellectual property rights. So this raises an important question. Can we actually build powerful AI responsibly and competitively? This paper suggests pretty unequivocally yes.
And that's exactly what we're going to deep dive into today. Stick with us and we'll unpack how they pull this off, what treasures are actually inside this massive new data set, and what it all means for the future of AI. So to really get why this paper is such a breakthrough, we need to understand the copyright conundrum, that tangled web that LLM training is caught in right now. The current landscape, it relies so heavily on pre-training. That's where models learn to predict the next token. You can think of it as a word or part of a word in just a huge sea of unstructured text. And this step, this foundation, it's absolutely crucial for getting strong performance later on. In downstream tasks, these data sets have just ballooned. We're talking trillions of tokens now.
Right. And if we connect this to the bigger picture, the de facto approach, the way people have been doing it, is just leveraging the public internet. Scrape everything. But the inconvenient truth, legally speaking, is that so much of that content is copyrighted. There are some recent estimates out there that are just staggering, compensating authors for using their work in pre-training, even at really low rates. It could easily cost billions of US dollars. And that's leading directly to all these lawsuits we're seeing now. The core issue is just this pervasive lack of explicit consent from creators. They never agreed for their work to be used like this. And that sharp mid-2023 jump in sites blocking crawlers, that really highlights how much owners are objecting now, doesn't it?
It's undeniable, yeah. A huge problem. So, okay, faced with this legal minefield, how did this paper find a way through? Well, they adopted a very, very strict definition for openly licensed text. They stuck right to the Open Knowledge Foundation's Open Definition 2.1, which basically says content has to be freely accessible, sure, but more importantly, it must explicitly permit use, modification, and sharing for any purpose. And crucially, this definition excludes stuff with non-commercial, that's CC/NC, or no derivatives ND licenses. Those might sound open, but they're not fully free for commercial AI training, which is often the end goal. So instead, they focused only on the truly open licenses. Things like Creative Commons Attribution, CC BY, Attribution Share Alike, CC BY SA, and also various software licenses certified by the Blue Oak Council, like the MIT license.
And this commitment, sticking only to truly open licenses, well, it wasn't easy. It created some pretty significant license due diligence challenges for the researchers. One huge pitfall they had to really watch out for is something called license laundering. This is where, copyrighted work gets redistributed, maybe by someone who isn't even the original rights holder, but with the wrong license slapped onto it. Imagine trying to build something critical, like a bridge, using materials where you just can't trust the label saying they're strong enough. That's kind of the trust issue license laundering creates for data. Because of this risk, the authors set these extremely strict standards. They even ended up excluding sources that might seem useful, like OpenAlex, YouTube Commons, even the Hacker News dataset from Kaggle, simply because they couldn't be absolutely certain about the licensing for every single piece. Another tricky thing they had to navigate was the use of collection licenses. See, a lot of these big web corpora like Dolma or FineWeb, they get released under an open license for the collection itself. But that collection level license doesn't necessarily, and often doesn't, extend to the copyright of the individual documents inside it. Those usually still belong to the original authors. So they had to be really careful not to mistake a collections open license as like a free pass for everything inside. And one more thing, they took a very conservative stance on LLM-generated synthetic datasets. There are datasets out there containing text generated by other LLMs, right? And some of those datasets have been released under open licenses. But if the original LLM that generated the text was trained on unlicensed data itself, well, the legal ground for applying a new open license to its output. That's shaky. It hasn't really been established. So just to be absolutely safe, they avoided any synthetic content from potentially tainted LLMs in their common pile.
Wow, okay. It sounds incredibly intricate, like navigating a legal and ethical maze. But it also sounds like they were really methodical, identifying exactly where the risks lay and figuring out how to mitigate them. Did they acknowledge any remaining caveats, like things they couldn't fully solve?
Oh, absolutely. They were very upfront about it. They state clearly that license laundering is just notoriously hard to stamp out completely, even with their rigorous checks. You might still miss some. They also noted that licenses aren't static. They can change over time. Their data collection snapshot was from late 2024, so any changes after that wouldn't be reflected. Plus, even within a public domain document, say a government report, it might contain small snippets of other material with unclear copyright status, like maybe a quote from an in-copyright book. It's a complex world out there, and they were commendably transparent about those nuances.
All right, so faced with this huge challenge, this legal minefield, they didn't just point out the problem, they actually went and built something. And this is where it gets really interesting. Their big contribution, the common pile, v0.1, like we said, 8 terabytes, and meticulously gathered from, 30 diverse sources?
Exactly, 30 sources. And what's fascinating here is the sheer breadth and depth they managed to achieve. It's not just scraping one type of text, it's this carefully curated collection covering so many different domains. And crucially, every single one was chosen specifically for its clear, openly licensed or public domain status. It's not just about size, it's about targeted, quality, ethical data diversity for AI learning.
Right. And they really seem to cover all the bases. Let's walk through some of the key domains, because the variety is really what makes this data set potentially so powerful. Okay, first, scientific and scholarly texts. Super important for technical terms, formal reasoning, that sort of thing. They pulled from sources like PS20, that's a collection of text from openly licensed scientific PDFs. Also PubMed Central for biomedical articles, and ArtHalf, focusing on the open access papers and abstracts. And here's a clever bit about ArcSev I found really insightful. Even if the full paper isn't open access, all the abstracts are CC0 licensed. Public domain, basically. That's a gold mine right there for initial data. Okay, then for online discussions and forums, these are great for learning conversational structure, how people actually talk. They use Stacked Exchange, all that user Q&A is CCBY-SA. They also tapped into the GitHub archive, pulling out issues, pull requests, comments, but only from repos with approved open source licenses. Plus, they included public domain Ubuntu IRC logs, so you capture that informal technical chat. Then there's government and legal texts, invaluable for exposure to formal arguments, precise language. Here, they use the U.S. Government Publishing Office for .gov documents, which are public domain in the U.S., the U.S. Patent Office USPTO for patents. And get this, patents have been public domain since 1782. Amazing source. Also, the Case Law Access Project and Court Listener for U.S. court decisions, again, public domain. And they even reached across the pond for UK Hansard, that's parliamentary proceedings, under the Open Parliament license. Think about the logical structure models could learn there. They didn't forget books in the public domain either. A huge source of rich language and historical context. Sources like the Biodiversity Heritage Library, tons of pre-1929 books digitized by the Internet Archive, the Library of Congress's digitized books collection, and of course, Project Gutenberg, and naturally, source code. Absolutely vital for coding abilities, logical reasoning. They use the openly licensed subset of the Stack v2 dataset plus Python enhancement proposals, or PPs, which are mostly public domain and gotta teach the models to code, right? And they even went further. They included transcribed audio content. They manually curated YouTube channels known to use Creative Commons BY licenses, then transcribed the audio using Whisper. And finally, web text. They processed snapshots from the Creative Commons Common Crawl, but carefully. They adapted a regex filter from the C4 Corpus project and did manual domain checks to be sure about the CC licensing. Plus specific sites like Fadista for recipes, some new sites that publish under CC BY or SA, and the public domain review.
It's just a monumental piece of data curation work, isn't it? It really demonstrates that diverse, high-quality open data is out there if you're willing to do the really meticulous, sometimes painstaking work to find and verify it. But like you said before, just collecting it all isn't the end of the story. Right? Once you have this massive, raw, common pile, what happens next? how do you turn it into something an LLM can actually learn from effectively? Exactly. That raw common pile, 8 terabytes, it's huge, but it needs some serious cleaning and structuring before it's ready for pre-training. So this raises an important question. How do you actually ensure quality and, just as importantly, optimize how that data is used, especially when you're dealing with such a diverse mix from ethical sources? Well, first, they undertook some really extensive cleaning of the data. This involved things like language identification, using fast text to filter out non-English text. They used a text quality classifier to weed out noisy or low-quality web content. They removed documents that had too many OCR errors, from scanned text. They filtered out toxic content using models trained on that Jigsaw toxic comment dataset. And crucially, they performed PII redaction, personal identifiable information, replacing things like email, phone numbers, IP addresses with generic tags like email, plus source-specific regex filtering to get rid of boilerplate text, headers, footers, that kind of thing. It's like sifting tons of ore to get to the pure metal. Okay, after that initial filtering, they did global document-level fuzzy deduplication. This is super important because having too much duplicate data is actually known to hurt language model performance. It can also increase the model's tendency to just memorize chunks of text, which isn't really learning. Their method was to consider 2 documents duplicates if they shared over 90% of their 20 grams. Think of that as overlapping sequences of 20 words or characters, a pretty strict threshold. And for the code data specifically, they applied some extra filtering heuristics, borrowing from projects like Red Pajama v1 and Small and M2, just to maintain code quality and focus on certain key programming languages. Then came the data mixing stage, this resulting dataset they called the comma dataset. And they found something interesting here. The raw size of a data source didn't actually correlate well with its text quality, or maybe its usefulness. For example, those USPTO patents. Huge source, terabytes of text. But the language is very unique, often quite repetitive, not like typical natural language found elsewhere. So they didn't just mix everything proportionally. They developed a heuristic approach to strategically upweight or downweight different sources in the final training mix. Their goal was to aim for a maximum of about 6 repetitions for the smaller but higher quality sources over the course of a 1 trillion token training run. So this comma dataset isn't just the filtered common pile, it's the remixed version, carefully balanced to optimize learning.
Okay, so the moment of truth. How do models trained purely on this ethical, cleaned, remixed data actually perform? They started, smartly, with some controlled experiments, using smaller 1.7 billion parameter models first. What did those initial tests show?
Right, they set up this controlled environment, training these 1.7B models on 28 billion tokens of data. They compared how models trained on their comma dataset performed against models trained on other openly licensed corpora, things like OLC, Common Corpus, KL3M. And they also compared against models trained on well-known unlicensed datasets like the Pile, Oscar, and FineWeb. And the breakthrough finding: the comma dataset didn't just do well for open data, it kind of blew the doors off expectations. It consistently outperformed all the other openly licensed corpora they tested. And maybe more surprisingly, it actually beat the Pile, a major unlicensed benchmark dataset, on most of the evaluation benchmarks they used. Comma models showed particularly strong performance on those scientific and scholarly knowledge-based benchmarks, MLU, ARC, things like that. And they directly attribute this strength to the common pile having such a large chunk of relevant text from scientific papers, patents, etc. However, they were also upfront about areas where the common models lagged a bit, specifically on common sense reasoning datasets, HelloSwag, PYQA, Common Sense QA. The paper speculates, and it seems plausible, that this might be because the common pile has less representation of certain domains compared to broad web scrapes, things like personal blogs, everyday tutorials, hobbies, sports talk, that kind of informal, common sense rich text. So it's perhaps a trade-off you make when you strictly prioritize verifiable open licensing over just scraping everything. Oh, and an interesting side note, they did an ablation study which confirmed that including that curated task data for the Data Provenance Initiative had only a minimal impact on the overall performance. Useful detail for dataset creators.
Okay, so from those really encouraging small-scale tests, they went for it. They took this whole approach to the big leagues, scaled it up to train those 2 7 billion parameter models, and they really doubled down on the open source principle throughout, didn't they?
Absolutely. They made sure the entire modeling pipeline was openly licensed. They even went so far as to create a custom BBE tokenizer. That's the component that breaks down text into the tokens the model actually processes. And this tokenizer was trained only on the common pile itself. So full ethical transparency from the raw data right down to the model's vocabulary. Now for the first big model, v0.1 trained on 1 trillion tokens. The results were seriously strong. It outperformed a whole slate of budget-matched baseline models, Llama 1.7b, MPD-7b, RPJ, Insight 7b, Stable M7b, OpenLlama 7b on more than half of the benchmarks tested. Its strengths really shone on those knowledge-based benchmarks like ARCC and MMLU, and the paper highlights particularly strong performance on code-related tasks too. And then they pushed even further with v0.1 2T.
This one was trained on 2 trillion tokens, which they achieved basically by repeating the 1T data mixture. In this larger model, it was competitive with some pretty serious players, Olma Twin, Llama 2, and DeepSeek LLM, again showing especially strong performance on MMLU, SIQA, ARCE, and the coding tasks.
Yeah, though it's worth mentioning the caveat they included about the 2T result, because they just repeated the 1T data mix. That much repetition might not be the absolute optimal way to use 2 trillion tokens. It could lead to diminishing returns compared to, say, creating a unique 2T mixture or adjusting the training schedule. So this raises an important question about the efficiency of data usage, especially with ethical data, and what the real returns are on simply scaling up token count versus optimizing the data mix and training process. And when you put it in context, you look at something like Qwen 3.8b, which was reportedly trained on an absolutely mind-boggling 36 trillion tokens, a colossal training budget. It really underscores the potential. Imagine what could be achieved if these large-scale ethical data sets were given comparable resources and optimization effort.
So bringing it all together then, what does this all really mean for us, for the field? The Commonpile v0.1, it feels like more than just data. It's a statement, isn't it?
I think so. If we connect this to the bigger picture, this work pretty firmly establishes a powerful truth. It is possible. You can build large, genuinely performant language models using only openly licensed content. No ifs, ands, or buts about needing unlicensed data for top performance at these scales, apparently. It feels like a really monumental step towards a more ethical, more transparent, and frankly more legally sound LLM ecosystem. The paper's key achievements are crystal clear. They built the biggest dataset of its kind, ATB, exclusively from open public domain text. They trained performant models competitive with unlicensed counterparts on similar budgets. And maybe most importantly for the community, they released everything. The dataset, the processing code, the model checkpoints. That fosters real openness and lets others build on this work.
It really does sound like a potential blueprint for the future of AI development, one where innovation doesn't necessarily have to tread on creator rights or navigate constant legal ambiguity. But I guess one question that comes to mind for such a massive, meticulous effort, what about the long-term sustainability? How do we keep something like the Commonpile updated and growing?
That's a really crucial point. And honestly, the sustainability often hinges on collective community effort and, well, funding. This paper provides an amazing foundation, a proof of concept that this can be done and done well. But the true long-term viability, keeping it fresh, expanding it, that's likely going to depend on ongoing contributions from researchers, institutions, maybe even companies who are dedicated to open science and ethical AI. It really highlights the need for shared infrastructure and sustained investment in building and maintaining these ethical data pipelines. It makes you think, doesn't it? What stands out to you most about this whole approach? What possibilities do you see opening up now?
It makes me imagine the possibilities if the whole research community really got behind this. If we collectively invested in expanding these openly licensed datasets even further, making them even richer, even more diverse. Could we actually reach a future where the default starting point for training foundation models is fully transparent, fully ethically sourced data? And could that lead to entirely new kinds of collaborative open AI development where innovation truly flourishes without those legal storm clouds always gathering? That's all for this deep dive. We hope you found these insights as compelling and thought-provoking as we certainly did. Till next time, keep digging for knowledge.